Hey everyone, we have a problem today to solve, and this is a problem that trips up a lot of people. So I thought maybe I will include this. This is a problem from this website that I maintain, and you can get more from that website. Entire introductory physics is there. Okay, so we have a situation where we have an elevator and counterweight. This is how the elevator is kind of maintained in its position. It's going nowhere. When in part A, it is no acceleration. So if this guy's acceleration A, and this axis is y axis, so this will be some ay. Yeah, so ay is 0 for part A, and part B, ay is going up, pointed up, is positive 5 meter per second square, and C, ay would be pointed down, so it's going to be minus 5 meter per second square. Okay, so let's see what question is about, not the elevator itself, but what's happening in the cable. Okay, but we're going to use the elevator's motion as to figure out what's going in the cable. Okay, so elevator has a 0 acceleration. So if I were to think of this as a system, you have a force that way in the cable, and then there's a gravity pointed down. If gravity is mass relative to mg pointed down, and these are only two forces, and that will tell me what the cable force is. And if I divide the cable force by the area A, perpendicular to the force, then that will give me the stress. All right. So okay, so yeah, all right, so here is a part A. I'm going to do FC minus mg equals to m times 0. This gives me FC equals to, and this is the acceleration ay of the elevator. So this is the equation of motion of the for elevator. And so this just mg, and so stress will in the cable will be sigma, will be just this force in the cable, and that force is acting over this area of contact. The elevator where they hang the area of cross section. So FC over the area of cross section, and that's mg over area of cross section. Okay, so now for numerical value, what do I do? Well, it says that it's 1 inch thick. This is 1 inch thick. That means the diameter is 1 inch thick. So it's given in diameter. So mg is, that will be 5 over 4 diameter square, and it's given in 1 inch. So I need to convert that into centimeter. So diameter will be 1 inch, and this is 2.54 times 10 to the power minus 2 meter. And so this whole thing, you can just put numbers. Let's put numbers. Okay, so numbers will be 4,000 for m kilogram, and g I'll just do 9.8 meter per second square, and then you flip this guy, gets 4 on this side, divide by pi, and d is 2.54 times 10 to the power minus 2 square. So I'll just put this in a calculator and get the answer. Let me get the answer by doing the calculator. I'm going to pause it and give you the answer. Okay, so I have these numbers. I just put them in my Python, IDL, and this is the acceleration, and I just wrote down the answer that I have it over here, and it says 77.4 megapascal. So that's the answer. So let's write that down. That's equal to 77.4 times 10 to the power 6 Pascal, or 77.4 megapascal. So that's the answer for the stress. How about strain? Okay, so let me get some area to work on. Okay, this thing is occupying real estate over here. Maybe I can just get rid of this. Okay. All right. To get rid of this very easy. So let's see the strain now. So what do we get for strain? Let me. Okay, so for a strain, we would use Hooke's law, and it's a stress is equal to Young's modulus and strain. Strain is delta L over L. So it's like a fraction change in the length, how much cable is extended per unit length of the cable. And this is the Young's modulus, and I wrote down Young's modulus of the cable was given in the problem, that, and sigma is what we found now. So epsilon would simply be sigma over y, and sigma is 77.4 megapascal, and this one is 150 gigapascal. Of course, this and this is 10 to the power 3. And so you can see it's roughly half times 10 to the power minus 3. Okay, so that's a you can calculate this out using calculator. So that solves the problem for A. So the answer for A is about 77 megapascal and about half times 10 to minus 3. So these are the two answers for part A. How about part B? How do you do that? That's the part B and C. Actually, A, nobody gets it wrong almost, because this is just formula application, and just if you're careful about this unit change, you should get it right. But B and C kind of trips people up, and let's see what changes will take place for B. So for B it will be you are going to get these two forces, but then the acceleration is pointed up, so this won't be 0. So that's the difference that's going to be. It's going to be FC minus mg. Minus mg is going to be m times ay, and so this will give me FC equals to m g plus ay. So if I go out there and convert that to sigma, will be FC over A, and A is the same, and you can see that this is just, instead of G, you're going to have a G plus AY, mg plus AY over A. So this is plus and this is plus for B, and for C this will be plus, but this will be minus for C. So let me write down what the C will look like. Sigma will be M 9.8 minus 5, and this will be M 9.8 plus 5 over A. So you can see that I really don't need to do a whole bunch of problems. We used to be 9.8 is over here is a 14.8. So M over A times 14.8, and this is M over A times 4.8. So this is basically what I found in A, sigma found in A times just 14.8 over 9.8. So I don't need to do more calculations, just scale it, and this will be same way. Sigma found in A 4.8 over 9.8. You can see that basically what I'm doing is multiplying by G and divide by G, and this part is what sigma in A is, and this is the part that either going to be for this or that. And so so this tells me this whole thing is sigma of A was, we just found 77.4 times this thing 14.8 over 9.8 megapascal. So there's a more here. So this is the factor that even epsilon will scale by. So and let me erase and just get the answer for you. Okay, so this one says that I've got 1.5 in one case and half as much. So this one will be 0.5 sigma A, and this is going to be 1.5 sigma A, and so that just 1.5 times, let's just call it 80 or something, just for the doing a calculation much more easily. So this one 120 megapascal, and this is going to be, if I call this 80 megapascal, this is going to be 40 megapascal. So it's going to have less stress. It's going to be way more stress, and then epsilon here, it's just going to, if this going to scale and this going to not scale, this going to be scale. So this is going to be 1.5 times half epsilon in part A, and that's 1.5 times half 10 to minus 3 is 3 over 2 this guy, and so 3 over 4 times 10 to minus 3, and no units here, right? No units here because this is ratio of length by length. And so in this case epsilon will simply be 0.5 epsilon in A, and it's going to be 1 over quarter times 10 to the power minus 3. So that's without doing any extra work. Once you get the scale that you need, how this changes here, you can just carry it forward, and that solves the problem. So why does this thing causes problem to people, and that has to do with they forget, it's not that difficult, but they forget that you have to set up, when there's an acceleration going on, you have to set up equation of motion to figure out what's the force in the cable. And because a lot of the problems people do doesn't have acceleration, and they just kind of ignore this, it leads to a wrong answer. Okay, so I'm going to stop here. if you like this kind of video, if you have some questions, don't forget to just leave comments in the below, or you can tell your friends and subscribe to this channel. We'll talk to you later. Bye.